small computing. That's how the neural net is reacting. So as soon as it gets stimulated, it's kind of a stimuli avalanche going inside. So it's a total parallel n-dimensional process. But every point here, every data point has a handle number. So I know exactly who is when doing what, and I can address it. And I can ask why. Well, because I was stimulated from that side. Now, if people know already concepts like Kohonen and others, you have those thresholds, And sometimes you're wondering, when you stimulate that, you had a 10 here, and you said, okay, if it's a 10, then you go and react. Now, you have some certain input, and it reacts. You have a different input, and it reacts the same way. Why? That's the kind of fuzziness you will find in given concepts. Now, the problem is, you didn't know how the 10 was born. Because the 10 could mean 7 plus 3, 5 plus 5. Now, if you could see that level on reaction, you would see that the same 10 is not the same 10. It's different. And that's why it reacted the other way or reacted the same, whatever you have. Now, we are on that level. We can tell you how the 10 comes together. So we know whether the reaction is because it's a 5 and 5 or because it's a 7 and 3 and so on. So we are one level lower on that. And we don't use this kind of levels and pre-adjustments and calibrations at all. So if data comes in, we are on binary level. So we recognize patterns on binary level inside this neural data space. So data comes in, and we can find patterns in this binary level, and then it will turn out into words or text or pixels, whatever. And we can show then that if you put this text in, and as I show it here, we can feed text without any space and signs and everything, just character by character, and the system will turn you out words. Because the patterns are still there. I mean, if you don't scramble the text, if you scramble it and it has no logic, of course, then there is no inherent semantic, and then the system can't read it. But as soon as there is inherent semantic, inherent content, then the system will turn it out. Because it will just see that the word B and E or E and I and whatever language you have, there is some pattern on that, and there's some higher patterns and some other patterns, and they belong together. And as more text you get in, of course, the smarter. It's like in school, as more you go to German lessons, as better you're going to work in this language. And that's exactly the same here. The only difference is it takes you 6 years to learn a good German. Here we can dump it in 5 minutes. And just import it. So far we had two main directions. We had the neural direction and we had the traditional direction. With traditional, I mean the more Boolean orientated approach. And both of them tried to solve the problems. And somehow, if you look at it from that point of view, it's clear that probably you should combine the two. Because also, in our brain, we are very good made for pattern recognition. But if it comes to calculate, well, there are some geniuses out there that can do big numbers in their head. But usually, we're going to use the calculator because we're not really constructed for that. But for patterns, we are. Now here, what we have created, AI1, is a kind of a merging. So it is a data space where we are using the traditional neural technique, the traditional Boolean approach, plus the data space is constructed in a new way, in a new type of very simple neural data space where you put all this information in. So you can put in, and you have a facsimile representation of your information, and it will find any information structure in any data, and you don't have to know what you look for. When I met Thomas Gelucci from DHS at the exhibition we have been, he said, okay, you got 30 seconds to tell me what you're doing with your company. So I said, I will give you an answer to a question you didn't know that you have to ask for. And he said, great. And he was standing for 20 minutes and all the others get upset because they missed to go to the other stands because then he had to go to the plane. So, you know, that's really what we're looking for. That's what we enable here. So it's a self-optimized information process. It's a self-controlled content organization. It's multiple higher order concept formation. And it's autonomic learning. It's self-controlled. We don't have to teach him how to learn. He's doing himself. He will bring back this information and then I can confirm or declaim. But you know, that's all done in this data space. And that's the most important thing. It has the ability to generalize. So when the pattern is recognized, it can generalize it and apply it into other unknown areas. And that's how we can find things we didn't have the idea to look for it because we even didn't know that we should look for that. The system will turn it to us and then we decide what to do with. And then in addition to that, because it can generalize rules, of course I can feed rules and tell him to use them generalized. And that's the way how I call it biological inspired, because now I give him my knowledge into that and he can apply my knowledge into those data. So, I mean, he's as good as I am. So if I'm telling him stupid things, he will do stupid things. Well, that's the good news or the bad news of really intelligent systems. I mean, they are as good as you feed them. But then, of course, if you get them a lot more information, the system will come back and say, maybe you're wrong. Because all the other information tell me the other direction. So, you know, it really will surprise you. It's also a controlling and over checking and validating process you can do with that. So finally, we change a paradigm. You know, the old paradigm said data is dumb and programs are intelligent. And we say that's wrong. There is information in the data already. You just have to find it. And the intelligence is not something you manufacture. You can't say, well, I deliver you this box and this is intelligent now. It's like if we hire the most intelligent and famous students of you and put it into our company. First day, he will be lost. He doesn't even have a clue what to do, even if he's the most intelligent one. We have to tell him. So you have to communicate with the system, and the communication then will create the intelligence. And it's not that it's all pre-manufactured and that's the best solution. So we say generalizing is one of the big keys, and then understanding the meaning, and then deciding what to do about and put it back into it. So this is really the way how we see it, and that's what we enable you. And it's content driven. Again, if you're using that technology and you apply it in medical, well, it will be a medical system. If you use it in fingerprints, then it will be a fingerprint system. We don't have to be the best on that. The specialist takes it and then he will apply it wherever he likes. So there are mainly 3 names you have to know. It's AI1, which is standing for the basic fundamental theory. That's the part which knows why a cell is behaving the way as she is behaving. And then we have, if it comes to imaging, we call it ultramatch. If it comes to text and data, we call it topic mapper. So those are the two elements or the 2 libraries on top of AI1. So AI1 is the basic, and then you have 2 different ones for either direction. And the reason is simple. For the pixel, we need a digital retina in order to clarify what the pixels aim for and you know, to have intelligence on the pixels. And on the text we don't need. We can go straight into the AI1 layer. That's why we have the 2. And then all the rest will be deployed underneath. And currently we are in biometrics, in forensics, in cosmetics, in medical, on the imaging side. We have some ideas on the robotics, I told, in the data mining and so on, so in the text orientated. But we started a little bit more heavy on the imaging side because it's much simpler to prove. On the semantic side, I mean, you ask, I'm sorry for that, 5 different professors of language for a certain text and you get 10 answers. So, you know, it's really hard to judge there. And we wanted to be in this discussion at all. So we said, okay, imaging is easy. Everybody of us is an image specialist, and you can tell whether this is the same or not. So that's why we started on that. And we'll leave this other discussion for later.